All right, this is the 11th session of the Mastering the Lightning Network Reading Group. We're going to be talking about Chapter 12 today, which is pathfinding. Pretty complicated stuff. We were just having a little bit of chit-chat about it here before the call gets going, or before the call got going. Does anybody have, Steve, it sounds like you had some kind of interesting thoughts about this before the call got started. Do you want to maybe mention what you were describing?
Well, I think this was just I was trying to with Christoph about he mentioned video games and search algorithms, and this A star algorithm they mentioned in the book is used as I mean I don't know much about video games, but I've read some books on the topic, and they use the same algorithm for search pathfinding in a video game world. And I think Christoph, you mentioned you'd seen similar strategies when you were playing with video game development.
Yes, I believe that was the one as a teenager. But at that time, I was my brother was 5 years older. He was a programmer. I know nothing. I learned everything just from screwing around, and he told me about that one, I think.
Yeah.
But it seems like with Lightning pathfinding, it's just way more complicated, because there is this element of uncertainty where even if a channel that is potentially a good part of a route, where it might have enough liquidity, but you don't know until you actually try it out. So there's just all this uncertainty in there, and it's interesting how nodes then build this terrain map over time, and they can still never be sure if it's accurate because the system changes all the time. So it's just I found it interesting how highly dynamic this is. Maybe that's normal for peer-to-peer networks, but for me that was an interesting aspect, how there's like a constant analysis of the surroundings happening.
Yeah. I think it is somewhat unique, actually, just like from what I know also about like internet routing protocols. Those protocols generally have all the available information. Like if you're doing an internet routing protocol, they know the link costs basically ahead of time. There's no secret, basically. Like I guess it's possible that a route could be extra busy routing traffic, but it sounds like in Lightning, they specifically hide things like this. I found interesting. They specifically hide the actual liquidity. So the capacity, but you don't know the liquidity, which is how much of that capacity has been used or is available. So that's hidden for two reasons. The one reason being, just privacy reasons. The other reason being, like, you don't want somebody, if all that information was known, then you could sort of continuously pull that and figure out how the money's moving around the network. But the other reason is also all those updates would probably flood the network. You'd be spending all your bandwidth just updating channel balances as every Satoshi moves across. So that's something else you don't want to do. So I found that also kind of an interesting observation. So that is interesting. And back to the video game analogy. In the video game, you would also have all the information. You would know what the map looked like, basically, or at least from your character's point of view, what they could see on the map, where the lava was or whatever, and avoid it in their pathfinding. You wouldn't run your character directly into something dangerous. But in this, we don't know. Like all those minefields are out there, and you don't know until you try to do a route and actually send a payment over them, and then they'll fail. So I thought that is a very interesting thing. And the other thing we were mentioning earlier before we started recording that I found really interesting is that none of this is part of the standards. So this is all, this is all stuff. I assume there's best practices. It's all open source. People look at what other people do, but this is probably an area where people as a developer will try to innovate and find better route finding algorithms or better ways to traverse and poll these routes. So that's actually kind of cool from a developer or user point of view, that different implementations might do it better, and people will grab it. People will just discover better ways to do it. And I suspect that is going to happen. Probably it's already happened.
And there's no harm in that. That's what's so great.
Yeah.
Is that if they find a better algorithm that path finds better, as long as they're ultimately sending other Lightning nodes Lightning messages that are compliant with the spec and formatting their HTLCs properly and all of that. It doesn't matter if one node is using a different pathfinding algorithm than another node.
Yep. Yeah. I mean, basically, what the user is going to see is they're going to see either they saved on fees or that they had more successful attempts with this client potentially. But yeah, that's all from the user's point of view. The network doesn't care. They just get properly formatted onion messages that hop by hop move their way through. And yeah, I think that's pretty cool.
If I got this understood correctly, the only time I've been exposed to this really is when trying to rebalance channels in, I think it's Write the Lightning, where when you want to do a rebalance, you actually check the route first, and it tells you how many hops it needs and what the fee involved is, and that can change. I've done smaller rebalances. Or I've tried different amounts of rebalancing because with the higher amounts, it was just too expensive. And then just reducing them a little bit gave me much better results. But I'm not exposed that to when making payments, but for rebalancing, I've definitely seen that.
So in a rebalance, I assume you're just sending value kind of back to yourself. Is that the kind of rebalance? That's kind of what the rebalance does. It moves it sort of from one channel to another channel, something like that.
Yeah, exactly. When when two of my channels are too lopsided, then I just try to get them more balanced by sending from one through some other people to my through my other channel, basically.
It's like a circular path kind of thing.
Yeah, that's actually interesting that you have a client. I didn't realize, I haven't played much with those clients that's an option they give you, which makes sense. I mean, this seems like the thing again in the future. Possibly wallets or Lightning wallets will do automatically for you. They'll look for opportunities, maybe like opportunistically, when they see an opportunity to give you a rebalance, they'll do it. If you just kind of tell them what your end goal, what you want, like if you want equally balanced channels or you want more outbound liquidity or more inbound liquidity or whatever you're looking for, whatever you sort of maybe some setting on your wallet, that'd be a cool thing that it just kind of it's always on.
How is the balancing side? I have been struggling with my node for last 2 weeks on trying to get a proper routing Lightning setup. So I have been rebalancing, and it seems like below above 100,000 sats, the rebalance almost never works, and I have to keep reducing the rebalancing amount. Otherwise, I'm not sure whether it doesn't find a route or it just times out.
That's interesting. Which client is this?
It's the same Write the Lightning with LMD.
Oh, okay.
Yeah, I don't know how a client like RTL would. It seems almost like it would be really difficult for it to be able to rebalance if it. I guess what I'm trying to say is it seems like if pathfinding is such a complicated endeavor, it would be incredibly difficult to conduct a rebalance and know that the rebalance is going to succeed ahead of time. Since just because of the nature of pathfinding, it seems like you're trying to find these paths that I think it has a higher probability of succeeding on this path than on this other path. So I'm going to try that. And then if it fails, I'm going to go to the next, one in my list that I think has a high probability of succeeding and try that. And I'm curious with RTL, maybe does it opt to find really short paths that it, for example, if you have a outbound liquidity with Bob and inbound liquidity from Charlie, does it attempt to rebalance just by using solely known paths? I don't know.
So one thing that I am seeing is the maximum hop of a rebalancing path I have seen for last 3 days is 10, and on average is 4 to 5. So within 4 to 5 hops, it generally finds a circular path between a well-known node. One other thing I have noticed, if you try to rebalance between a channel or rebalance between two peers which are not very well known, like some random peers out there, then the path tends to get longer. So suppose if you want to, if you have a channel with Bitrefill and if you have another channel with say LND, and you want to rebalance the channel between Bitrefill and LND, it will probably find a path between 2 to 3 hops, because these are like well connected nodes, so it generally finds a quicker and shorter paths. But on the, like, if you have a random node with your peer channel with your friend and random channel with your another friend, and if you try to rebalance, then probably it will go for a longer route. So mostly, in RTL, it asks for a maximum amount of fee that you are willing to spend. So if a path like exceeds that amount of fee, then it will not do the rebalance, and for any path below that maximum fee rate, it will do the rebalancing. The maximum fee I have observed is like, for a 7 hop path, it was like 200 sats, but on average, the fees are like varying from 20 to 30 sats for rebalancing.
Gotcha.
That's
But in general, I
I
feel like a rebalancing is just like sending another payment. It's just like a payment to yourself. So the Lightning Network doesn't care whether the payment is where the payment is going. It just does the same thing as for like doing the like normal payment stuffs.
Okay, so it sounds like my initial. Oh, I'm getting some nasty echo from somebody. Yes, it sounds like my initial assumptions were correct, that when you're doing a rebalance, it is subject to the same pathfinding complexity as any other kind of payment, and also has the same chance of failing multiple times, the same way that sending any other payment would.
wonder if also something that comes into play here is something else I talked about in this chapter, which is, you have all of the capacities of all the channels, but then as you route payments, as your node is actually, you're actually making payments through it, and you have failures and successes, your node learns about the actual liquidity in these channels. So if you have a node that you don't actually do very many payments with, like if you were on a like a Bitrefill or something, you're making connections all the time and making payments all the time, you would have a lot of information of success and failure. But if you're you've got your own personal node, you don't send a lot of payments, or maybe, I guess it's just sending. You only learn on sending. So unless you're making a lot of payments, you might not have any real fresh information. So that could hurt you too, in terms of success probabilities.
Yeah, that's another interesting thing I didn't knew, and I learned in the chapter that it actually tries to actively guess the amount of like the balances on each side. So
Yeah,
I
it's
also
almost
tried another thing, but like in the start of the book, they says like there is a code in the the book repo, and that like displays and calculates the graph. So I tried to do that, and I tried extracting like the full graph description from my node, and it spits out this JSON data. And this JSON data basically has two components. One is like the list of nodes, like public keys with their internet IP addresses, and then there is a list of channels, like all the edges between connecting two nodes. So that was interesting. I found my node also in that graph data, so that was cool.
that is very interesting. Yeah, it's all out there.
Okay, while you were chatting, I did a rebalance because I wanted to see it, and I rebalanced 100K sats, and the estimate was 4 hops and 1.1 or 1,100 millisats of a fee. Then I did that, and it cost 77,000 millisats, and it was 5 hops in the end. So that's clearly that estimate and what actually happens. There can be very big discrepancies.
I just, you don't really know until it happens. So it gives you an estimate, and then it'll find whatever it can find once you say go.
Even if it's 70 times as much in fees.
Yeah, that's a little. Yeah, it almost seems like you want to put a cap on it,
Yeah.
Yeah, you can do that. I think there is a way to cap it, and yeah, I'll have to use that next time.
Yeah, most time like when I see like when I capped it, it fails. Like it doesn't do it. But like I have never paid more than like 200 sats in last 2 days of trial. So even like 200 sats is like quite a huge amount just to rebalance your channel.
Yeah.
70,000 millisats. That doesn't sound too bad. That's only like 70 sats, right?
It's 77 sats. Yeah. My routing earnings from this month are 22. So got a lot to optimize there.
Yeah, what I'm finding right now is like if you have like a very small channels, like the amount of cost that you need to put for rebalancing is like greater than the amount of fees that you earn for routing. So probably it's better to have like bigger channels and not to like rebalance too frequently, because the cost of rebalancing can outgrow the like the fees earned.
Are there any features to, instead of doing a manual rebalance, a way of just sort of changing your fees in one in one direction? Would that work? Like you're trying to move sats in one direction, right? So can you do something with your fees? Or I guess it would have to be, yeah.
You can update the fees for per channel basis. Like you can say like for this particular channel I will have this much fee, for that particular channel I will have that much fee. You can do that, or you can like in general set fees for all the channels.
Okay, but I wonder, is there a way to use that to rebalance over time?
What do you mean by like using the fees?
Well, let's see. So like you've sent channels from you. So you're A and you sent, you're like, if you're trying to rebalance a channel from Alice to Bob. So you've, for some reason, I guess all of the sats have gone on to Bob's side, right?
Yeah.
So you want to get half of them back to your Alice side. Is there a way to adjust your fee? Like, because what you want to is if you can somehow say that the fee from Bob to Alice.
Oh, I see. Yeah. So if you can like offset the fees in that way so that more payment flows from that direction to this direction.
Right. I don't know if that's possible or not.
That will be difficult, because like when Bob is sending you the payment, the fee is taken up by Bob. So it's Bob's policy, not your policy.
I see, right.
So only the payment that is going from you to Bob is like if fee is taken up by you, so that's your policy. So you can only update your policy, not Bob's policy.
Right. That makes sense. Yeah, and I guess if he, so that's another possibility. So that's maybe the other way to look at it. So if I'm Bob, not Alice, I'm Bob, and I've got I want to make payments. I want to balance that channel I have with Alice. I could drop my fees very low or maybe zero. Maybe that might be, I know there's some discussion on Twitter about why would you have a zero fee channel? And that might be a reason. If I'm Bob, I have all the sats on my side of the channel, but I want to balance it. I could set my fee to zero. That would encourage people to use it in the Bob to Alice direction, maybe.
That's some cool trick. I'm gonna try it next. Let's see.
I've heard other node operators tell me that that's something they do on their nodes to, it's kind of a, different way, alternative way of rebalancing.
Mm-hmm. It might not happen as quickly, but if you're not in a hurry anyway.
Exactly.
Also, in that case, assuming you don't go zero, say you just went one sat or something small like that, then not only aren't you paying to rebalance, but you're getting a small fee for someone else to rebalance you.
Yeah, exactly.
Possibly. I don't know. What are typical fees? Like, what is like a typical channel fee today that you guys find useful, like find works on your channels?
So by default, LND sets the channel fee like 1,000 sats, 1,000 millisats of base fee, like one sat of base fee. Then it's like 1 millisats per 1,000 sats or something like that. The exact term they use for fee is fee rate in millisats. So fee rate means like the rate of fee, it's depending on the total amount of payment that is being sent. So the total fee is the base fee summed plus the total amount multiplied by fee rate. So in the graph data that I have extracted, what I am seeing is like people have mostly put the base fee as 1000 millisat, and the fee rates are varying from, I am seeing 1776 to 1 to 773. So it's not like a standard. By default, LND will give you like 1000 MSAT base fee and 1 millisat fee rate, but then you can like update it accordingly. I am seeing some guy have put 1700 millisat at fee rate. That's the max I think I have seen in the graph data. Oh, there is 74,243 millisat fee rate. So with base fee of 24 millisat. So somebody has like really like offsetted their fee calculation in the fee rate side.
That's actually another balancing strategy I bet people use, which is, so say I'm Alice and Bob again. I start with, say, I don't know, I start with 10,000 on Alice's side. As I get to a balanced channel, as I get 5,000 on one side, I then might want to raise my fees quite a bit in that direction just to try to keep it balanced, right? Like I don't want other people to take my liquidity potentially if I want to keep that somewhat balanced. I could potentially on the fly raise the fee as I get more unbalanced because I don't want it to get to zero on my side, something like that.
Yeah, probably. And probably I think like people are like actively managing, like updating their fee policies all the time. I'm not sure.
So.
And I have to like experiment and figure out how much it's effective and to rebalance my channel, because for now I am seeing rebalancing is one of the biggest pain of like managing a routing node, because your channels are constantly being knocked out of balance as payment are flowing through.
Yeah, there's actually a podcast I listened to this weekend from Matt and Marty, and they mentioned somebody had a Twitter thread about how to run a profitable Lightning node. I'll see if I can find it. I'll send it to you guys because I haven't checked it yet, but I'll see if I can find it and put it in the thing. But apparently there's some threads. This is from, they were talking, the particular episode they were talking about the plebnet, the plebnet Lightning node operators. And
yeah, I think I have seen that thread, and I also talked with that guy, asked him some basic question like what kind of channel management tool he is using. And this plebnet is basically a Telegram channel where they have like a cohort of like Lightning node operators, and they are like constantly discussing and like throwing suggestions to each other. They also have a very good wiki. Like the guy who created this plebnet, who probably like have been trying to set up his lightning routing for a long time, and he has like summarized all his experiences and all the tricks and hacks that you can use in order to like manage your channels and all. And they have like maintained a nice wiki that is like very helpful like when you're trying to like do this on your own.
Yeah, I think that's what I was thinking. Yeah, they have I just looked at the wiki now. They've got running a section on running a profitable node. So I guess that's where the info's at on plebnet.wiki.
Yeah, there's a lot of really good information among plebnet.
One of the one of the things that I wasn't clear that I'm interested in the multipath payments is so let's say half of the payments go through in like 5 different ways, but can it actually fail? Could there ever be a situation where it says, well, sorry, we could only deliver half of the amount because there's no liquidity for the rest of it? Just if that's even a possibility, or because there's no way for the node to just say, okay, I could only deliver half, I'm going to take back the ones that succeeded. That's not possible, right?
Yeah, so you're wondering, like, if it's split into 5 paths, what happens if 3 paths succeed and the other 2 paths fail?
Yeah, and that they cannot be resolved even after multiple rounds of trial and error. Could it take back the ones that succeeded? Which probably not, right?
I think so. But I'm not gonna.
Well, multipath payments are supposed to be atomic, but I was also looking for that question in this chapter, and I didn't see any mention about how they were atomic. I mean, it didn't really mention it in this chapter, so I don't know if anybody else. Maybe it's going to be in another chapter they mention. I have to look ahead and see.
Yeah,
That is a good question.
I'm not going to pretend like I understand the answer, but like obviously, like we talked about like in chapter 8 and more in chapter 9 with the concept of like HTLC and how essentially the secret needs to be back propagated among every person in the payment path, so that essentially it makes it so that everyone along that path is incentivized to back propagate the secret in order to reclaim their money from the HTLC. So if I had to take a guess, I would say that there's probably a much more sophisticated chain of HTLCs that are involved for multipath payments that makes it so that all of the payment paths must succeed. But I don't know.
My guess is, I'm not exactly sure, but my guess is the way they make it atomic is like the final payment secret is not revealed until all the payments or all the parts of the payments are combined together at the receiver's end. So the receiver will only like reveal all like the final secret that will settle all the different parallel paths of HTLCs when all the parts are received. So if some parts fail, then the sender will try to like resend those failed parts again until they succeed. And if they don't succeed, then none of the parts that have already gone through, they also doesn't settle. So they all trace back or timeout or something like that. So that's how they make it like atomic, like either all of them like reaches their destination or none of them does.
That makes sense. Yeah. So I guess by extension, that would mean that they all have the same secret, like they're using the same secret for all those sub pieces.
Yeah, and this is like the vague idea I have from like from Rene's some talk in Chain Code Lab. It says like the hash of each HTLC, the payment ID or the hash of the secret is the same, but the secret is like revealed when all the different parts of the HTLCs come together and they do some computation on the different payments that has been received, and then that computation reveals the secret that matches with the hash of that HTLC. So until all the payments are actually in a single position where they are like combined together to recreate that secret, then the hash of those HTLCs will not be matched, even though all the HTLCs have exactly same hashes.
Yeah, so you're absolutely right, Raj. It's far simpler than I thought, and you had it absolutely right. It's just as simple as the person receiving the payment does not reveal the secret until they've received all parts of the payment. When the recipient receives the first part, they won't immediately settle the HTLC. Instead, the HTLC is accepted and held, similar to how HODL invoice payments are accepted. They could settle because the pre-image is known, but that wouldn't be a rational thing to do. Settling right away would return the proof of payment to the sender, while the full amount may never arrive. With the proof of payment, the sender could claim that the payment was made in full because all parts use the same payment hash. Another possibility that may be even worse is an intermediate node uses the now public pre-image to settle the second HTLC without forwarding it all. So the recipient waits for the second HTLC arrive. They then conclude that the full amount has arrived, will at that point settle both HTLCs. So to answer your question, Christoph, no, I don't think that there's a situation where parts of the payment could succeed and the other parts couldn't succeed. I mean, in theory, if there was a bug and the recipient revealed the secret, without doing that, yeah, that would compromise the payment being received in full. But as long as the recipient is withholding the secret until they've received all payment paths, then it should remain atomic.
Got it. Makes sense. Thanks.
I think it says in here now. It said in here somewhere that they all use the same secret, right? All of the payments. It said that somewhere in here. I think they use the same pre-image on all of the paths. So I suspect you might also have a problem with timeouts. Like if for some reason one of those, not just that it failed, but maybe it took too long because you're waiting for all of them. You could get one of them times out, which forces all of them to time out. But yeah, that's very interesting. I'm surprised he didn't mention that in the chapter, because that would have been good information in this particular chapter.
One thing that they did mention in the chapter is like this MPP or multipath payment is already like part of the protocol. So I was wondering, like, does LND or C Lightning already does this like under the hood? Because in my channel management stuffs or RTL or anywhere, I haven't like seen any glimpse of it, like it's doing some parallel paths or something like that.
I see something about it in the L&D docs right now on the Lightning Lab site. I just, in that same link I pasted in the chat, I'm just like clicking through the docs now. Yeah, atomic multipath payments are a new type of Lightning payments implemented by L&D in version 0.13.0 beta. So assuming what we're reading here is correct or up-to-date docs, then that means that you can do MPP, or at least atomic AMP, which I'm assuming is the same as MMP. You can do that in version 13 beta of L&D.
Okay, so I'm running probably version 13.1, so it probably does this under the hood, and it's not a client-side thing, so it doesn't ask the user whether you want to do it or not. It's probably like decides on its own, like when to do it.
Yeah, that would make sense, because I know they were talking about in the book just like the kind of the probability math. It's like, okay, how many paths does it have to do? The more paths, the higher the probability of failure. How large is the payment? If it's too large, the larger the payment, the higher the probability of failure. So, maybe there must be something in the probability calculation. If the size gets too large, then it's like, okay, we need to start thinking about doing this multipath.
Yeah, probably like something like that.
One general thing I liked from the chapter that's completely unrelated to the technical side of this is just the reference to I think it was a Lewis Carroll book or something, or some old school writer. It was just the idea of the creating a map that's a 1-to-1 ratio of the territory, and it eventually becomes completely unusable as a map because it's the most completely accurate map in existence. It's down perfect down to the exact detail, but in creating such a map, you've recreated the territory, and so it's completely impractical as a map. And there's just this idea that if you try to think of the Lightning Network in the same way, that if you tried to create an absolutely perfect map of the Lightning Network down to the last detail, even assuming such a feat were possible, you would have then recreated the Lightning Network. So we just have to accept with maps that they're not the same as the territory.
Yeah, maybe more like they're supposed to be hints, which is kind of what it is. It just kind of sends you in the right direction.
Yeah,
that's interesting. You got a little poetic there with the Lewis Carroll stuff.
Yeah, I like when they do that in the book, when they bring up little tidbits like that from stories and stuff to help make it I don't know, just to kind of humanize it a little bit more.
Yeah. One thing they did mention that sort of reminded me of too, there used to be, you've all heard of Ethernet. Ethernet also uses this thing called spanning tree, which is a type of way to stop loops from happening in the network. And I think it's not directly related to this, but it's got a similar thing where it basically hears messages and learns about other nodes on the network just by the messages flowing through I don't think anybody uses it anymore, but it used to be really popular to have a big spanning tree Ethernet where it starts, just pruning its own connections based on information it learns on the network. So I don't know, that's another old school technology that uses some of this, that this is kind of reminiscent of. But yeah, anyway, that's just one of the thoughts.
Did they mention anywhere in the book like how they are like sorting like different paths, like the probable candidate paths, and then trying them out one by one?
He does mention that. He mentions in this sort of trial and error loop thing, I think he says something about that.
But which one to try first? Like the lowest fee path, like it tries first?
I mean, like, how does it calculate that rank?
My guess is it would be the lowest fee would be the first one, but I haven't like seen anything specifically mentioned on that.
It seems to me like this could be something that, like we were discussing earlier, this is the kind of thing that could really vary from one node to the next, or one person's software to the next. It's still compliant with the Lightning protocol, but it almost seems like you could prioritize for different things when you're doing your candidate search.
Yeah, seems like, because it's not a part of a standard, so every implementation is free to do their own thing for it.
Now here's a question to expand on your question. Would there be a situation when trying to pathfind? Would there be a situation where you would want to optimize for something other than lowest fee?
That's a good question. Lowest fee, I guess your probability of success also goes down depending on how many hops you have. So you might also care about that. I'm just looking at previous chapter, I think chapter 12. They did talk a lot about the fee metrics and the channel metrics, and maybe that's where this question gets more answered, was last chapter, I think.
You mean chapter 11?
Oh, was it chapter?
I think we're on chapter 12 this week.
Right. That's pathfinding, yeah.
That'd be fun if we were all talking about a different chapter the entire time.
Yeah, wait. Oh, the link in the book is wrong. That's why I'm looking at week 11. No, I see. This is week.
Well, no, it's week 11, but chapter 12.
Right. So gossip and channel graph. No, yeah, okay. I guess I am talking about chapter 12. He does. Where is that? He talks about this. He has like some formulas about maybe.
Sorry guys, I missed the last part. Somebody was at the door. I had to like open it. So
I was just looking at the part of this chapter where he says liquidity, uncertainty, and probability, and he has sort of a formula here. But I don't think it says specifically in the chapter how they rank those routes. We were also sort of mentioning, so under fees and other channel metrics, just talking about that stuff. Yeah, I think I was saying the other thing you might care about besides fees is just that you might care about how many hops you have. That maybe if the fees were equal, you would probably take the path with fewer hops, because that might have a better probability of success.
So in the link that I have sent, like they have like a list where it kind of like a list of like process that which they select a path, and with the point number 3, they says like order the paths by some weight. So probably like they use some kind of like weight metric for each channel, and then they select the path of least weight. Something like that.
It would probably be a weight for each metric, right? So you want to weigh fees greater than.
So it depends like how this weight is like defined, right? The weight can be like simple fees, or it can be like something else. It can be like the HTLC time lock delta also. Like if a channel has a more delta, then you might not want to go there, because if something goes wrong, then you have to wait longer. So probably it is probably implementation dependent also. Like different implementation might have like different definition of what they mean by the weight.
Yeah, because he says, most Lightning nodes and wallet implementations improve on this blind probing approach by ordering, weighing the list of candidate paths. Some implementations order the candidate paths by cost, fees, or some combination of cost and capacity. That's probably the most critical one there too, because if something is, if the capacity is low, if one path has a lower capacity, then you're more likely to fail. That's probably a more accurate measure of success. If it's a high capacity channel, you're more likely to have enough liquidity there, right? So that, but I think it gets back to what you said, Raj, too, is that it's implementation specific, but they generally improve on the kind of dumb approaches and use additional information to make that ranking. And then I suppose you're also going to look at information about prior attempts you've made to probe the liquidity there, and so it's have that information possibly too.
Seems like a lot of moving part goes into this, like these codes, and like I wonder like how they are managing all of that inside.
It's a lot. I mean, a node really is doing a lot to keep track of all this information.
Well,
and also like the informations are like very quickly getting out of date, right? So if you have like things from like 1 day ago, that might not be applicable at all anymore.
Yeah, you can see how if you were a large node with a lot of high capacity channels, you would do a better job routing than some sort of edge node. And I don't know if we've talked about it yet or if they've talked about it here, but there's this concept of, I think it's a trampoline node, something like that, where you just send your payment to another node to do the routing for you. And that could be sort of more of a light mobile client. I think Moon Wallet might do this. And that could be a very good reason, is that a not well connected node really does have a lower chance of finding a good path than a well connected, always on sort of node. So that's a interesting sort of takeaway, I think, from all the complexity in the routing, is that it does put you as a small node at a disadvantage not just disadvantage in terms of your channel capacities, but in terms of, since you're not making frequent payments, you're not learning about the actual liquidity as a heavily used node probably does. That's interesting. Not that it's impossible. Obviously, people are still doing it. You just might be at a small disadvantage.
Yeah. So we're about 45 minutes in here, so I think I'm going to go ahead and turn off the recording here and open up for free discussion. I just realized when we started doing this reading club back in July, there was 12 chapters in the book then. This was the last chapter that was on the main branch of the book back when we started. So I think for a while now, I was thinking this was going to be the last one, but it looks like they've been hard at work, and this is no longer the last chapter. There's now 17 chapters in the book. So we now have,
oh my gosh,
we have 5 more chapters before we can say that we mastered the Lightning Network. So yeah, like I said, I'm going to turn off the recording now, but we can get to chapter 13 next week. Okay, here we go.